All right, so to begin with here, we got to describe why we need logs, because that's what your next big test is going to involve, a lot of log stuff. What do we need logs for? They go hand in hand with exponentials. For example, if we were going to take 5 to the x and make it equal 7, x must be some number just like a little bit bigger than 1. 5 to the 1 would be 5, and it would be a little bit bigger, like 1.2 or something like that. So you could guess, and you can actually guess logs correctly by looking at that and saying, oh, 5 to the what would be 7? It's about 1 point something. I don't know, maybe 1.2. And it actually is pretty close to 1.2. How do I get it exactly? Logs. I'm going to, oh, by the way, though, just one of the things I've told you over and over and over again would work on the ACT test on many, many problems. How could I solve this? Graph both sides, see where it crosses. It always works. Okay. Cool. So this thing, both sides and see where it crosses. Exponential, it look like this. This is the line y equals this, where us alignment's up. That's where the answer is. Okay, so anyway, if I'm gonna solve the x logs, though, and this is it's called, and that's some other number we argue about. And see where that comes in a moment. It's 5 of 7 equals x. The way you write these is you take this, you in the log base 5 of 7 x. Now, this is it's called the exponent. That's why I said we argue later about what it's called. Okay. And that is, and again, oh, that doesn't look like an exponent when I write it this way, but remember where it came from. It was the exponent. Now, if you type in the calculator, you're going to get about 1.2. How do you put it in? You put in log 7 divided by log 5. Try it. Grab your graph calculator. I'm going to pause for a second while you do that. Okay, so type this in. You go log 7 divided by log 5. 1.20 even? Wow. 1 point, I get around to 1.21. But anyway, remember now, you're typing this thing in, it's important that you use parentheses at the end after you typed in the log 7. Here's why. If you type in log, it'll automatically put up a parenthesis. And then you type in the 7, you have to end the parentheses. Okay? Log 7 parentheses divided by log 5. Now, why does that matter? Because actually try it once without the parentheses. Try typing in log 7, in no parentheses, divide by log 5. You will not get 1.21. You'll get something close. 1.00 something. So it's off by like 0.2. And it happens often that kids will get an answer that's off by 0.2. It's because they forgot the parenthesis. Okay, so don't forget that. Now, what did we get there? We got the exponent that solved the problem. That can go back in here. 5 to the 1.21 would be 7. It wouldn't be exactly 7 because we rounded this. So, of course, this will be off a smidge. All right. The most important thing you need to do is to take something like this and rewrite back and forth between logs and exponents. So this one, if I were to rewrite this one, it would be log 10 equals jump x. And then you could type in log 10 over log 8. Now, we won't be using calculators that much on this unit because we're going to depend on a lot of patterns. Like there are a lot of problems that you can solve without a calculator because you can just know what the answer will come out to be. All right, let's talk about that for just a second. We had log base 8. That is a really common one. Just 1. Now, if you think about that, what would you put in the calculator? Log 8 over log 8. Just by logic, wouldn't that be 1? Uh-huh. Okay. So, this to 8 squared. What do you think the answer is now? 2. It is 2. Now, here's a couple reasons why. You could explain it this way. In logs, you're allowed to take any number that's on the exponent like that and drop it down in front of the problem and rewrite it that way. Now, that's 1, that the answer should be. Okay, another way to show you how this one would work is to say, I don't know what it is, so I can set it equal to x, and then I can solve for x. How would I do that? This is a log. Just a second ago, I showed you how to take an exponential right as a log. I could take my log, rewrite it as an exponential, and say 8 to the x equals, I didn't know what it looks like when I do this. Do you get, therefore x must be 2? All right. So there's a couple proofs, but the point is you need to recognize that whenever that will be the answer. So the questions aren't, of course, going to be log base 7 of 7 to the third, because that would be too simple. The answer is 3. But it might be something like this, 49 in there, and then that 49 could really be, what, 7 squared, and then, of course, the answer is 2. Or the problem could be 1/7 right here, which stretches you a little bit on the whole exponent thing. 1/7, same as 7 to the -1, and therefore the answer is -1. And remember, when I say the answer is -1, that means I replace this whole thing right here with a -1. So if I had like 2 times log base 7 of 1/7 is equal to 14x, this is an equation I could solve, and I know that this whole part right here was -1. So 2 times -1 makes -2 equals 14x, and from there, that really easy. Divide by 14 on both sides. How did I know this was -1? Because part right, 7 to the -1, and once I've made them have a common number, then the one is the answer, -1. Okay, so here's another pattern you need to know. Well, the answer would be 12. If these two are the same, then that one's the answer. You get so much fun. Are you looking at videos or something? All right, good, stay there. Is the two are the same, then that's the answer. I'm going to you, and it's going to blow some people's minds, and some people are going to be able to handle it. See if you're one of the people that can handle it. I'm going to say equals x because I don't know what this thing is equal to right now. Now, would you agree that even though this has a log in it, that it's actually an exponential? So if it's an exponential, I can rewrite it as a log. And so I'm going to say log of, and then I jump over there, x is equal to, jump back, log base 8 of 12. And if log base 8 of x and log base 8 of 12, if these two are the same, then these two have to be the same. The answer is 12. Get that? All right, so if these two are the same, that one's the answer. I've proved it to you. Now you don't have to go resolve that every time. If you see a problem like this, squared log base, let me think this through, 1/16 to the -1 of 10, then you'd be able to go, okay, 4 squared is 16. Okay, so this is really 16 log base, what is that really? 16, 10, and now you know the answer is what? 10. You wouldn't have to go up this big long equation, equals x, and do 16 of x is equal to log base. You can just, know the pattern. These two are the same, you know the answer. Okay, yes? If this is 1/16 put to the -1 power, which makes it 16, it doesn't work. If these two are not the exact same thing as each other, it won't work. But it will sometimes look not, like if I say 1/16 here, and let's see this, 4 to the -2, I like it. Okay, see how they look different, but they're actually the exact same thing? And so the answer is whatever comes next. Let's say I say 32, then the answer is 32. All right. These two are exactly equal to each other. They can't be like close. Like I make that just a 4, doesn't work. Yes? There's 2 reasons I can think of. One is just that, get out a base in itself. It's a base, and this thing is the exponent. And then the base of log, so they share the same base, really. That's their way to think of it. Anyway, and the long way to prove it is set it log thing, and it's a long time, but you're going to have to be able to recognize this pattern. If these two are the same, that's the answer. Okay, moving on. So much to cover, lots of little things. You're going to have to be able to rewrite something like this as 4 to the power. Like, why would you care that that's 4 to a power? Because maybe the problem says this, log base 4 of that. And then you really wish this to a power. Well, you can make 4 to a power. Try it. See if you can handle this one. Try to make that 4 to the something. That is a cube root of 16. That's on the bottom. That's saying the problem is log base 4 of, and I really wish that this was 4, because then I'd have an answer. And it is 4 to the something if I only can handle that. The alignment gets off and it just messes everything up. Okay. Okay, so now I'm going to really 4 to the something, but I'm going to rewrite my problem. I'm going to say log base 4 of 4 to something. What? Everybody got it? Would you agree it has to be negative so it can be a fraction? Do you agree it has to be squared somehow to make it? That's the 2 part is the third root. And notice when you have parts to this, you have the negative. That's plain old ring, whatever number. And then this is the root. Notice the roots are on the bottom just like in plants. Okay? So now let's try another one like that. Let's say you had for 10,000. And you really write that as 10 to the something. Because the problem is like this. Log base 10 to the what? Replace this whole thing with 10 to the, do you really need a negative to make it a fraction? 10 to the negative, and then it's either 4 or 3, and a lot of people get confused on this. That's a bigger number than you'd think. 4. Here's why. Would you agree if I had 10 to the 4th, I could put a 1 times in front of it, and it's not going to change it at all, right? Times by 1? Then, do you look at scientific notation? I'm supposed to move the decimal over 4 spots, right? See? So it works. It's really easy to think it's 10 to the 3rd, and I have often got confused on those myself. Don't feel bad. All right, so this part right here, can be changed to 10 negative 4. And then, negative 4, answer's negative 4. Okay, there's a lot of kinds of problems that we have to be able to handle. Let's go on to talking about LNs. We've learned about logs. What the heck are these LNs? They're really simple. Anybody know? Okay, I'm going to start this way. When I was talking about logs, I would always say log base 3 of 12 or whatever. But it has something, and it's just kind of assumed. 10. We don't have a base written. That's called the common log. That means it's a base 10. That's why on your calculator you have a button that's called log, because that is a base 10. Your calculator can't do every base in the world. It can do base 10. It can do base E. That's what ln is log base E. So when you see ln, the way to make all those problems super simple is if you ever see an ln, like I say, it says ln of E. The word, the log base E, and I'll realize, oh, an E here and an E there, and the answer's got to be what? Hey, John, you're distracting not only yourself, but the person behind you. Set that down. Just flip it over and set that down. Thank you. Log base E of E is what? 1. And what that original like this, ln of E. And it doesn't really intuitive to me that answer. But as soon as I rewrite it as log base E, two are the same. Answer the exponent on that. How about this? E to the ln of 8. Answer's 8. Because the ln is really a log base E, right? Oh. Okay, here's another one that you should have, like, back pocket for log base 5.73 of 1 would equal, I guarantee you, 0. I'm trying to make the point that this could be any number. I don't care what that is. If this is a 1, then the answer is guaranteed to be 0. Why? Because if I put this to a 0 power, I will get 1. No matter what this is, right? Okay. So, moral of the story, whenever there's a 1 here, your answer is 0. So even if I said log A of 1, I know the answer is 0. Because if this is a 1, the answer is 0. The only flaw with this would be that I'd have to limit it and say A has to be what? Greater than 0. Yep. This can't have zeros or negatives. This spot and this spot, you cannot have zeros or negatives. Lot to learn about logs. You learned this last year in 8 days, and so we've so far had about 18 minutes. We've covered most of what you learned in 8 days last year. Not time for lunch yet. We're getting real close, though. I want to hand this worksheet out, do one to you, and then it'll be time for lunch. Hey, I get the same lunch as you do, so don't worry. I won't let you out too late. I think there's 3 there. I think there is. You don't. Remember when we did that beginning one where it was log 7 over log 5? You just type in the argument first.
Log 7 over log 5 would be log base 5.
If you're going to put that in, you type in log 7 over log 5. It would be nice, and in fact, the new operating system, the brand new one, they type in both numbers. I'll just do it for you. But okay. I've just handed out the worksheet. I think you'll find that the first few are really kind of no-brainers. And let's do a couple of them. Number A, or letter A. 4 to the x equals 4. X got to be. X must be 1. And you'll see in a moment that these are mirrored below as problem number 1 goes with A. Problem number 2 goes with B. But kind of like helpers. So let's do B. Let's think through B for a second. You would be x 6 to the x equals 1. How can I make that work? The only number work would be what? 0. X has to equal 0. Now what does this represent? Like log base 6 of 1 equals 0, because if there's a, it's kind of like problem number 2 down below. Anyway, part C, as in cantaloupe, is 2 to the x equals 32. Is, let's not go there, x is, because 2 to the 5th is 32. It's like log base 2 of 32, and then I could have said this was really like 2 to the 5th, right? You're going to do that all the time, where these bases the same as each other, and as soon as I say, oh, that's really 2 to the 5th, then the answer's got to be the 5. All right, lunchtime. Out now. All right, we're back from lunch, and we're doing a couple problems together. Let's jump down. I think you're going to find that D is one of the ones that is, there's a lot of that kind of stuff on this test. So would you go to D? I shouldn't say on the test, on this worksheet. Letter D says 5 to the x equals 1 over 125. This takes a little more thought. If you could only write this as 5 to a power, then it would make it easy. And what is it? So 5 to the negative third is what you should change this into. Once this turns into 5 to the negative third, then all of a sudden it's easy. X must be negative 3. So what's that like? That's like a problem where it would be log base 5 of 1 over 125 equals x. And you'll have to notice that little pattern where you want these two to be the same as each other. So that needs to change into a 5 to a power. And then when you got the power, the answer will be the power, negative 3. All right. Moving on, let's jump down to number 8. That confuses people sometimes because it's got two things going on. First of all, there's no base. What does that mean? The base is really 10. Very good. And then the other thing is that 10,000 could be written as a 10 to a power, and often people say 10 to the third, and they're wrong. What is it? 10 to the fourth. That's really 10 to the fourth. And now the answer's easy. It's just the exponent. So the answer's 4. Now, how did I know that was 10 to the fourth? I would challenge you to just say 1 times 10 to the fourth, and you'll see that it's scientific notation. And where you take a 1 and you move the decimal over 4 spots. 1, 2, 3, 4. Yeah, it'll make 4 zeros, and there we go. All right, moving on to number 2, not 12, that's too easy. Let's skip over to 13. Go to 13. Okay, number 13. Number 13 is L to the 3. What did I say you should change L to? Log base E. And that means, oh, the E's are the same, and therefore the answer is 3. It's easy as pie. Okay. I don't want to go through and do all of these for you. I will help with 15. Number 15, what was my advice again? When you see L, what are you supposed to do? You change it to what? Log base E. Now remember, I'm getting a lot of people saying these wrong. Just so you know, that is not log E when I write this in. That is log base E. I want to make this. You don't want to be the kid who doesn't know how to say it correctly. This is base A of B equals C. So all you need is the word base here and the word of there. Base A of B equals C. Okay? 2 words, base and of, to say it correctly. Okay, anyway, so now that I've got it set up like this, wouldn't it be nice if this was just an e to a power, and it can be e to the what? -1. So therefore, all of a sudden, these two are the same, and therefore the answer is the exponent. So there's 2 steps in that one, just knowing that ln means log base e. And the second one, knowing that 1 over e, e to the -1. Right. I don't want to do all these for you. You got to have some to do to practice for yourself. And I know that each one of them just has a little thing, but you can ask kids near you. You can work together. There's 26 questions, but it should go pretty quick. It's pretty easy. Okay, that's all I got for today.